This section is about saving for the long term by building your nest egg. The takeaway from this section involves the idea of preparing for the future by saving now. The article below gives retirement tips for young adults, with the first recommending that young adults start saving early, even if the amount is small. In the previous section, we discussed how an account grows if a lump sum is invested. Many long-term savings plans, such as retirement accounts, combine the growth power of compound interest with that of regular contributions. Such plans can show truly remarkable growth. We look at such accounts in this section. Let's look at a plan where you deposit $100 to your savings account at the end of each month. And let's suppose that the account pays you a monthly rate of 1% on the balance in the account. That is an APR of 12% compounded monthly. At the end of the first month, the balance is $100. This is the money that was deposited at the end of the first month. At the end of the second month, the balance is the $100 that we previously deposited plus the interest on the $100, that is 1% of $100, plus the new $100 deposit. The result is $100 plus $1 plus $100, or $201. The table below tracks the growth of this account through 10 months. Note, at the end of each month, the interest is calculated on the previous balance, and then $100 is added to that balance. For example, the balance after 3 months is $303.01. This comes from the previous balance of $201, plus the interest paid on the $201, plus the new monthly deposit. This table works well for finding the balance after relatively few deposits, but imagine trying to use it to find the balance after 300 deposits, or worse, 1,000 deposits. To do that, we might use a spreadsheet program such as Excel, or the following formula. This formula gives the account balance after a given month, assuming regular deposits at the end of each month are made. The formula states that the balance after T monthly deposits equals deposit times the quantity 1 plus R to the T power minus 1, divided by R. Here, T is the number of deposits, and R is the monthly interest rate, APR divided by 12, expressed as a decimal. Example 1. Check to see if this formula agrees with the balance at the end of the 10th month as found in Table 4.2. That's the table above. That is, we want to make sure that this formula gives us the same balance that we would get using a table similar to the one above. Recall, in the scenario above, the APR was 12%, or 0.12. This means R, our monthly interest rate as a decimal, is equal to 0.12 divided by 12, or 0.01. That matches the 1% interest rate that we've been using to help calculate our monthly balance. Since we are looking for the balance after 10 months, and we make one deposit per month, T, the number of deposits, is equal to 10. Finally, we have the amount we deposit each month is equal to $100. Substituting all of this into our formula, we get the balance after 10 monthly deposits is equal to 100 times the quantity 1 plus 0.01 to the 10th power minus 1, divided by 0.01. You should pause the video now and use the calculator that you will be using for homework and exams to calculate this quantity. Then resume the video and make sure your calculation matches mine. After substituting this into my calculator, being careful to use all the parentheses you see here, I found the balance after 10 monthly deposits to be approximately $1,046.22. Note, it is preferable that you do this calculation all in one step, as financial calculations are extremely sensitive to rounding errors. However, if you choose to do it in multiple steps, you may do so as long as you are careful to use the proper order of operations and round as little as possible until the very end. Only when you are finished with your calculation is it appropriate to round to the nearest penny. Notice the balance after 10 monthly deposits we calculated using this formula matches the balance found in Table 4.2.